Ladies and gentlemen, hello and welcome on our next season of the CBK PAN Engineering Seminary. Today we have a really special guest, a type of mythbuster. Exactly, a mythbuster. So we are starting from, let's say, an explosion, and trust me, the next episodes will be, I hope so, even bigger. So right now, let me introduce a little bit our today's guest lecturer, but I'm really sure that you know everything about them. Well, so Jamie Hyneman is a special effect expert engineer and an interpreter, best known as the co-creator, the co-host of the television program MythBusters. He is the founder of M5 Industries, a special effect workshop in San Francisco originally focused on visual effects, prototyping, and engineering solutions for the film and advertising industries. Under his leadership, M5 became the primary workshop featured on MythBusters, where innovative builds and experiments were created to test popular myths. With a background in industry design and a decades of hand-on engineering experience, Hyman has become a recognized authority in applied science, robotics, and practically problem solving. So, as the best engineers do, they solve problems. So today he's going to talk a little bit about VTOL technology advantages and implementation. Okay, one more thing, because I know that our guest would prefer to answer your questions, to talk to you, not only to talk by himself. So, I would like you, if you would have any questions, I'm sure you will, write them down on our chat or here at the Zoom connection, or perhaps if you prefer on our YouTube channel. Next, I will read those questions, and of course, our guest will be glad to answer them. So here we go, Jamie.
Hi, I'm in San Francisco in my shop, and uh, I've been using this shop, the same facility that we shot Mythbusters in, for about a decade now, doing various prototypes, some for private industry, some for the military. And I guess the main reason that I'm here now is that one of the things that I had developed for the US government was a counter drone, which was designed to autonomously hunt down and shoot down small drones, like hobby-sized drones that are capable of carrying something like a small grenade or other explosives, and you know they're small and agile, and very problematic to deal with, as I'm sure you know from watching what's happening in your neighborhood, actually. So this machine, it's not able to deal with something like the larger winged drones that are carrying large quantities of explosives. This was something that was about a meter and a half in diameter, and you know, weighs about 25 kilos, I believe. It's capable of going about 160 kilometers an hour, and it's arguably one of the most agile aircraft ever designed. Its aerodynamic or aerobatic capabilities are off the hook, because it has it's kind of like the Osprey, the U.S. Osprey, in that it's a winged aircraft, but the Osprey just has one set of wings that tilt. This has four wings, and each one is independently tiltable. Can we go ahead and pull up the video of that and show it? That's not the one. Um, yeah, this has nothing to do with the jump ship. Um, since I think, well, while they're looking for that, I can talk about the jump ship. This is an example of a similar type of a device that I didn't design, but the company that worked with me on developing my product, the H-wing, developed this jump ship. And it's in some ways better because it's simpler. This is able to take off VTOL in that position that it's showing right now, like a quadcopter basically. But then once it gets airborne, it lays over and is able to fly like a plane as fast and as efficiently as a plane. This particular item here is, I think, about 3 meters across, and it's able to carry around a payload of 5 kilos in that center column. It goes also like mine, it goes about 100 miles an hour, and it has a range of about, I think it's around 90 kilometers or so. So it's not as formidable as one of the simple winged aircraft that the Russians are sending that are Iranian made or whatever. And those can carry much larger payloads and do a lot more damage. But this is a design that, unlike those, this does not require like a runway, and it actually is a reasonable approach to producing a drone that's very agile. The fact that it doesn't have a like a pronounced tail like mine did, or my H-wing, which we'll hopefully be able to pull up a clip of before long. It's able to change direction very rapidly. It doesn't have to flip a long tail thing around to go in the opposite direction. It can just rotate on its own axis instantly. And in the case of mine, which we'll hopefully see here shortly, we have mobile wings that are able to allow to do that. So the jump ship is obviously, in the case of these drones, you want to have something that is able to that is versatile in that it can take off without a runway, that's very agile, and ideally as simple as possible. So this is a good a good example of that. But let's see, where else was I going with this? Um, you can pull this online, up online. This is made by a company called Transition Robotics, and you can see a lot of what the other stuff that they've done. The agility and if you're just to make the point with this stuff, if you make something like the jump ship or mine that is a thing that weighs like 20 kilos or more, and you're trying to outmaneuver a little thing that weighs maybe 2 kilos, like a little hobby drone, a quadcopter, you've got to be able to it's a tall order because the little quadcopter like that, because it has so little mass, it can just change direction instantly. And if you're trying to swing around something that is 3 meters across and 20 kilos, it's got to move all of that mass into a different direction. It's very difficult. And so this was for me. This was an exercise in trying to claw back some of the agility that you have. Like, if that's not obvious by my description, if you've seen some of the larger octocopters that are maybe a meter or more across, they carry a professional movie camera setup. uh, they're if you're going to change direction on those, like you're hovering like this, if you want to go over that way, then you've got to shift all of that mass like this, and you start to drift over. With mine, I've got wings that are mobile, and I can just go like that, and off I go. It's an exercise in clawing back some of the agility that you lose by increasing the mass, which you have to do if you're going to carry a lot of payload, like a weapon, or explosives or something like that. So if you're countering these drones, these larger, or if you're countering the small drones that go after individual soldiers or can destroy a vehicle or something like that, as I describe it, if you're you may say a mosquito is not near as fast as a 747, but it's a lot more agile, and so that's the difference that you're trying to deal with. And in my case, I made, unlike the osprey that just has the one wing that can tilt, I have four, and so its aerobatic capabilities are just off the hook. And it's able to, even though it's much larger, it's able to compete in agility with a much smaller drone. So that's the kind of thing that I developed. Are we looking for that clip? Do we have that? The the H-wing? That's all jump ship. Um, this was not on Transition Robotics site. Tomek has that. So if you can find that, that would be good. But anyway, I'll just go on and describe what's on the H-wing, since we're on that topic. It has on board a fully automatic belt-fed machine gun, which is a lot less violent than it sounds, because it's actually a modified air rifle that's made to shoot small lead pellets. Now, we found when we were doing testing that these smaller drones, even with a firearm, they tend to, the bullets or the projectiles tend to glance off the hard plastic shells on these things. So, not that you can't actually penetrate them, but you have to get in exactly the right spot with that projectile. Because if you're off to this side or any place other than like a perpendicular surface that it can hit and blast through, it's going to glance off. So we found that something like 90% of the projectiles fired at one of these small drones don't penetrate, and even if they did, the I think it was something like only about 6% made it into a critical component, and in all likelihood, that was going to be the battery, because that's one of the largest critical components in a small drone like that, and that may well take a certain amount of time before it shorts out completely. So in many cases, the battery is able to actually last long enough to um, to allow the drone to complete its mission. And oh, so we're okay. So we're not. We're pulling up other things. I'll get to the zero obvious stuff in a little bit. We're looking for an untitled thing to do with the H-wing. It's not on. It's not available online. Tomek should. I sent the video link to that.
I just tried to call Tomek, but he doesn't answer. So, if Alan doesn't have it, I'm sure I do not have any copy of recording from you.
Okay. Well, I'll
I'm
just
very sorry.
okay, well, so I'll complete my description of it. So this drone, it fires. Well, as I talked about, these projectiles. If you try and shoot something that is to penetrate one of these small drones, in all likelihood, it's not going to hit something that's going to stop it. And we measured this. We have actual percentages of success rates and so on with that. So what I did instead of that is I created a gun that is able to fire tiny Kevlar kite string bolas. So these are our well, a bola refers to something like that a gaucho would swing around and throw it at you know at say a small animal of some sort or a cow or whatever to entangle their feet and make them fall down. It's a rope that has weights on either end of the rope, and let's say in the case of what a gaucho would throw, that might be, I don't know, a couple meters or so long. In the case of ours, it was about a little over a half a meter long, and there was a specially designed pellet on either end that I actually spent a couple of months creating, and because what happens is this when it's fired at one of these smaller drones, it gets sucked into the propellers that the drones are relying on to stay aloft, and it entangles them. Now, these small drones have very sophisticated systems to maintain their balance because what they were mainly created for was to have cameras on. And so, as you can imagine, if there's a gusty breeze or any kind of turbulence at all, if they weren't able to counteract those gusts, then you're going to have a unsuitable image. So they react instantly to any kind of interference with what they were supposed to be doing. That is what we were capitalizing on because if we have entangled one of these bolas on a prop, on one of the four props, uh, these small drones are going to do everything they can to try and counteract the instability that introduces. And what we found happens typically is that you'll end up with one of the bolas stuck on a prop. The other three props try to counteract what that one is doing, and they accelerate, which causes the drone to flip. And once it's flipped, it goes down. These are 100% effective. Once they get on one of these small drones, it's going down. And so we carry on board about 150 rounds of these things. They get stuffed into the belt, like the machine gun belt, has a series of small little tubes that are linked together. That's what makes the belt. So we basically I made a machine that will take one of the bolas and stuff it into one of those little tubes with the pellet as corks or plugs on either end of that length of string, and it's able to fire about 30 of those a second when it comes in. So we found that on average it takes about 12 rounds. And we carry 150. It takes about I guess it's zero point 0.4 of a second worth of firing to land one of those on a targeted drone, which this does autonomously. And I can't tell you how it works autonomously, but it's you can probably find it. Boeing has took over the project to manufacture it. I'm not sure. It's a Boeing subsidiary that did that. And let's see. So zero point 0.4 of a second, about 10 to 12 rounds. We carry 150 on board, so we can take down a dozen or so of those small hobby drones on one mission. And so that's how it works. The other interesting things to note with this is that this drone, which I call the H-wing, uh, I think the Boeing subsidiary renamed it Midas or something like that for their own reasons. But um, with this is a tandem winged drone. Sorry, I'm stumbling with this because I thought we'd have the video, but to describe it, it's a tandem wing drone, and the fuselage is basically the same proportion as something like a shipping container or a truck body. It's a rectangular tube that has a nose cone and a tail cone on it. And then in the front of it, it has a pair of wings, and in the back of it, it also has another pair of wings. And each of those wings has a prop on it, and they're all independently servo controlled. Now, what this does is that when, as I showed the jump ship, when it takes off, it has its wings aligned vertically, so it goes up. And then once it gets airborne, it lays over and it can fly like a plane. With ours, when we're on the ground, we make the wings vertical like that, and we take up and take off. But then once we're airborne with the servos, we go like that, and off we go. And so each wing independently moving, each wing has a prop on it. So the sneaky part of this is that once we're airborne, we because we're mobile like this with the wings, we can tilt the fuselage, so we can stay, hovering or whatever with the wings like this, and therefore the fuselage is aimed like that. Now, that allows us to put this weapon, the machine gun, fixed mounted like an A-10 Warthog. And so we're able to, we put that just like the A-10, we put it along the center of mass so that when it fires, the recoil or, backwards thrust that the machine gun makes doesn't throw the aircraft navigation off. It will slow it down a little bit, and the A-10s were noted for doing that. It actually the gun that they have is so massive and powerful that it actually slows the aircraft down while it's flying. So they have to give it more throttle or something. So In our case, it's not that bad, but it was designed to be able to take care of that. And because we can tilt the fuselage, that makes it this thing like an A-10 that can stop and hover, which is a frightening prospect because these are tank killers and things like that. So they go as fast as a normal military jet, but then they can stop. This can stop and hover with this design. So and that goes right back to our premise that we wanted to claw back what agility that we lost by having to have this gun and this larger aircraft than these small agile hobby drones. So if we had to put that gun outside with its magazine or its belt feed or whatever, all that stuff starts to mean that we have more things that we have to push through the air. So we have bigger batteries, we have bigger motors, we have all this stuff that we have to do that kind of feeds back on itself, and we get bigger and slower. So I put that gun inside. Therefore, we're much more aerodynamic than we would be otherwise. And by the addition of these servos that move the wings, we're able to move so aggressively that this thing is actually impossible to control without autonomous controls, at least at its upper limits of its performance. So when we go out and try to outmaneuver one of these small drones, it's doing stuff that is so off the hook, you can't even see it unless you film it in high speed. So that's my story with this. This was, you know, once I developed it and proved the concept, then it was taken up by, as I said, a Boeing subsidiary, and what they've done with it, I can't speak to, but at any rate, that's sort of where I came, or why I'm here talking. We develop. I've done that. It was built in about a year with a team of different experts, including transition robotics. The flight controls were all a single line of custom code, so there is no, if there's anybody in the audience that knows what goes into the kinds of programming that stabilizes these small drones, this was this is not was not a pair, not a combination of VTOL programming for the drone that then jumps over to winged flight uh, controls. This is one line of code, and the thing autonomously decides uh, how the controls are working. The I guess the point with that is that we would have a certain loss of control in that jumping to from VTOL to winged flight, and given that it's entirely possible that a smaller drone could find that it needs to fly at something in that transition zone where we would be hopping back and forth between winged flight stuff and VTOL stuff and the software. We decided that we needed to do custom code so that there is no transition. It just does what it has to do, and there's no jumping back and forth. Um, so I think that's most of what you need to know. I'm sorry that we didn't. Oh, it looks like am I? No, I'm not seeing. I thought I saw something there with the
Yeah.
jump ship, but
We're
uh,
very sorry about it. Really try to fix it. Unfortunately, we weren't able to find the movie of Sand, and I'm sure it would bring a lot to your talk, to your lecture. But let me get this straight. Well, it looks like I have a first question. You were talking about a drone that is faster than the military aircrafts and is as big as a truck.
um, no, I'm sorry if I misspoke about that. This design certainly would scale. So if it was desired for it to be that large, I mean, then one could do that. I intentionally, what I think would was giving you that impression. I spoke about the shape of the fuselage was the same geometry as something like a
Okay.
truck.
Okay,
And
so I'm very sorry, but perhaps I,
no,
uh,
and I'm glad you brought that up because that's important. The reason that I did that is trucks and shipping containers, things like that, that are these, long boxes. That's how we transport stuff. We generally don't like, if you look at, for example, an Osprey, which is a conventional, tube shape in its fuselage, or any jet airliner or whatever, those are very specific, and they're not all down to business, which is just like if you got stuff you need to move, we put them in boxes and shipping containers, and we carry stuff around that way. So that's how I designed this thing.
okay,
This was all business as far as because we wanted to put like we had to put this weapon inside it and all this electronics, and we wanted to keep it as compact as possible. And as somebody that does not design aircraft for a living, this was my first attempt at doing something like this. I'm coming at it from a different point of view as an engineer, and I wanted a box. You could optimize it by making it more tube shaped or something like this, but in looking at something that is a flexible platform that you can put whatever you want in it. You could, if you scaled this up to say something the size and shape of a typical school bus, for example, uh, that's what you want to put if you were going to put a bunch of soldiers in the air, or if you wanted to make, if you want to put school kids in there, that's the design that you want if you're making something that is practical and efficient and so on. And so that's what I did. We could see this scaled to the size, as you asked, of a truck. And this is the modern school bus that will take kids from anywhere to anywhere. And you just have them lined up in their seats along the sides of the bus, and that's very, very efficient. So that was what my reference was. And in our case, though, to be clear, what I made was about a meter and a half in diameter. And that was intentional because that's just big enough to put in the back of a pickup truck or a small van. You don't need, like the jump ship, for example, that is, we were looking at that's 3 meters long. And so there's certainly trucks that can handle that, but they become more specialized. I wanted this to be something that you could, you could even put one of these in the back of a conventional car.
okay.
Um,
Sorry for my misunderstanding, but thank you for the
no problem.
clarification. So we have a question from our colleague Adam Sikorski. Uh, do I understand correctly that the control algorithm was capable of controlling eight parameters uh, to four angle of wings rotating with uh, respect to, I'm very sorry, I can't see it widely. Okay, okay. The second that control algorithm was capable of controlling eight parameters for four angles of wings rotating with respect to fuselage and for, I'm really sorry, I cannot read it, throat to each other. Perhaps
Um,
it would be better if you try to check the chat to
Yeah,
be
so
capable of.
hi, hello. I just wanted to ask if I understand correctly that your
Oh,
control algorithm and the overall control over the drone was controlling the independent angle for each of basically four wings and motor for each wing.
I believe you're correct that we have four four electric motors with props on them. So you're controlling those. We have four wings that each wing has its own separate servo on it. And just in case this clarifies something, the this box shape that I described, the fuselage, is in the front of the box. There is a block of carbon fiber that goes from one side of the box to the other side of the box, and in that are bearings and servos. And there's a cable drive system that goes from the servo to the wing axle. So basically, and it's the same in the rear or the stern of the aircraft. There's these wings which are subject to ridiculously aggressive forces when it changes direction. You've got this, 20 kilos of stuff that is going in one direction, and then the blink of an eye, it's going in another direction. So that wants to snap those wing axles or rip the wings off. And in fact, we had and this is for the nerds in the group, the engineers. We had one surprise that came up. That motion that I talked about, the ability to change direction like this, it caused one of the prop motor axles to snap because of the precession, because of the gyroscopic forces that were put on those propellers. There is no aircraft that was ever made that I'm aware of that does this. This is able to take that prop and have it change its orientation like in the blink of an eye, and that in fact snapped the motor axles, which would have been fine otherwise. So if we were to take this device further, we would have to, double the conventional size of the motor shaft that holds onto the prop to deal with these gyroscopic forces. So, at any rate, in answer to the question about you've got essentially right. I believe you've got four props to work into or four motors and props that you have to work into the software, as well as four wings that the props are mounted on that can rotate. So that is, you're correct. That's eight different things that have to be integrated into this one line of code. which is that I would point out also again for the nerds in the audience, the largest expense in this was in the coding. So
I can believe it clearly. I have one question to our technical department. Can I have the permission for screen sharing? Tomek just sent me this video that you
Yes, you
mentioned, so
can.
I would like to share because right now I have an information that I cannot share my screen because this option is not available for me.
Alan, there should be Alan somewhere. Mhm.
Okay, so maybe in meantime, I have one more question regarding the video that I hopefully will be able to share with you in a second. Uh, Basically, from the jump ship description, the jump ship design, and your description, I understand that there are basically aerodynamic wings also on this drone, and on this prototype, it looks like there are no airfoils basically, so it's only four motors on rotating shafts instead of wings. Was that the change that you implemented in the future, or was that the overall the
I'm
end
sorry, the audio is not super clear on what I know you're talking about the jump ship, but you'll either have to talk more slowly or we'll have to repeat what you said.
Okay.
Can you repeat for what?
Adam said that he's gonna be back in a second. Perhaps there is something with his connection, and then he's gonna repeat the question.
Okay.
So, okay. So, are there any more questions, perhaps from the CBK PAN, from the floor? Oh, Adam is coming back.
Okay. Hi, hello. Can you hear me a little bit better than before?
Yes.
Okay, that's great. So first of all, Tomek just sent me the clip that you mentioned. So hopefully I will be able to share it in a minute with everyone, but I'm waiting for permission. And oh, okay. So I think we've got it. So
That'd be
hopefully
great.
that was the clip that you mentioned.
Okay, yeah, that's it.
Yep.
Uh, it looks like the video is a little jerky, but you can see that's the kind of thing that I wanted to show. So I would point out that this does not have wings on it. We had another version that does, but the other version didn't have the gun on it. This one does, and so you can see how it's able to angle the fuselage. The reason we did that and didn't put the wings on it was this was a development project that I had 1 year to do, and I wanted to be able to. I didn't want to risk putting everything on the one aircraft. We had one that had the wings and the motors in the same configuration that this one does, but this one was designed to just go after a small hobby drone and shoot it down. So we just did the simplest way that we could, and we didn't bother to go ahead and put the wings on it and worry about that on this one. But you can see how it's able to do that by rotating those prop surfaces, which are where the wings get mounted. And what you can't see is that we're able to move those independently. So it's not just two. You could get this to be clear. You could get the same movement by just having one servo in the front and one in the back. but we have four. So when we're talking aerobatic maneuvers, this can do barrel rolls and other things that are just totally off the hook. And so, as you can imagine, if this is able to do this so aggressively that it snaps one of the props off its shaft, you can understand why I wanted to, eliminate variables and test this before we went and put the wings on it. It actually that broke in flight, and this one crashed. But we were able to demonstrate and deliver for the government by contract as we were required. So there you go. So Adam, is it? Did you had some other questions about this, right?
Yeah, so basically I had question, but during your last explanation, you answered it, so it's no longer valid. Basically, I was asking if I understand correctly that there was a model with airfoils, basically. So I just pointed out there are a wing missing from this model. So yeah,
Okay.
so that was my question.
Ah, well, thank you. Do we have other questions?
Is there anybody else? I'm just trying to look on our YouTube channel. There is nothing. So, are there any questions from the floor? It looks like you said it all.
Well, there is one other thing that I would throw into this. This was also an interesting project in that in the way that it was run. I this shop that I'm in right now, we have the ability to build just about anything, but as I mentioned, I had never designed and built an aircraft before. And so I did what I normally do, and what I did all through MythBusters is, if there's something that I don't know how to do or I don't have the equipment to do, I find somebody that does. And so in this case, I got people like Transition Robotics that were capable of doing all of the flight control software, because that's what they did with the jump ship. They've already developed things that were designed for transitioning aircraft, going from VTOL to winged flight. And they used again, for the nerds in the audience, they used what is normally a research software called Paparazzi, but the military wanted to they wanted us to use a more readily accessible software that other people were familiar with, and so we had to translate that, as well as the jump ship doesn't require control of servos like that. It just does what it does by controlling the motors. So it's a relatively simple thing. But anyway, my point was how this was run was we had a carbon fiber subcontractor. We had Transition Robotics doing the aerodynamics and flight software. We had a company that had specialized in developing custom drones for inspection of wind power generation, so that their drones were designed to go run along the surfaces of the blades on windmills, looking for corrosion and stuff like that. So they were used to developing these smaller drones, custom ones to do specialized purposes. And I'm here in these other subcontractors were in different locations. I'm here in San Francisco. I was running the job, and I used GrabCAD and GitHub, and we communicated via Slack. This was all coordinated using tech like that, and it greatly facilitated what we were trying to do in a short period of time. So I thought that's something like and I'm sorry. Also in our facility here, we did all of the machining, the mechanical stuff, and had to develop things like the. I found a point of again, for the nerds in this, I found that timing belts, like the tooth belts that tend to be favored for controlling mechanical connections between a servo and anything like we did with, we didn't try to have the servo direct drive the wing shafts. We stood the servo off to the side and connected with it, initially thinking that we'd use a timing belt. So these are, I'm sure most engineers will be familiar with timing belts. They're toothed rubber belts. They were not sufficiently accurate. We tested them, and even though they were like we were able to pick them for testing that were within specifications in terms of their limits, we found that at the upper ends of their limits, there was slop. And so I developed my own cable drive system that is that did not have any kind of it has effectively zero um, uh, um, uh, I guess errors in movement right up until the point of failure. And if you, I guess, to put that into perspective, this was something that I learned from designs that go into computer chip manufacturing. They would often have in robotics, they would where they have to go from a servo to a rotating part. They will have like a steel band that links them. And obviously, for something like that, you can't really do continuous rotation, but we didn't need to. We were able to do 360-degree rotation very effectively with a milled stainless steel cable that did multiple wraps in a kind of spiral, and was terminated on the drum by using by drilling a tangential hole in it. So it anyway, that's the kind of thing. That's where we here at my company come into play, because I have a great deal of experience with those kinds of mechanical linkages, and we have CNC milling machines and so on, and so we did that. We 3D printed the nose and tail cones. We did carbon fiber. The main fuselage was carbon fiber. Um, uh, yeah. So I could go on with all sorts of nerdy things like that, but um, that just gives you an idea of we on this one project we spanned from using all sorts of tech communications, like what I'm doing right now with Zoom, to software, to all manner of hardware and aerodynamic engineering and so on. So it was quite the project.
Okay, we have one more question. Szymon Grabarek asks, can we see any of the solutions? Are they custom for this project or will be developed separately?
Um, they were custom for this project. And I briefly mentioned that this was deemed successful. I delivered on time, on budget. The military was happy, but and they had me bid on taking it to the next level, which would have been a manufacturing prototype. This thing that I built and that you saw the video of, it was a proof of concept. And I'm not an aircraft manufacturer. I am good at coming up with concepts and proving them. But so I did that, and then that's where the subsidiary of Boeing came in, and I they took it from there. That's because that's what they do, and they made about a half a dozen prototypes that were somewhat different. I can't talk about what they did that was different because that's not I'm not in control of that. But I can tell you that I was involved with providing them with the machine guns, um, because I'm now proud to say that I'm the world's foremost expert in pneumatic, fully automatic, belt-fed Bola shooting machine guns. So I developed those. I optimized the pellets, which were quite something. I spent 2 months on just working on the pellet design, which, because of the fact that once these get snagged onto a prop, they kind of work like a weed whacker, and they start hitting other things on the drone that they've hit, and so it tended to break the pellets off. And I figured out a pellet design that wouldn't do that. You had that alone was kind of again a nerdy thing that I had to get into. These pellets, or these bolas rather, they, as I said, they have the Kevlar kite string is about this long, so a little over half a meter, and on the end of it are these small pellets, and they get stuffed into the little tubes that are about 25 millimeters long. And so I could have increased the strength of the Kevlar string by making it a larger diameter, but then I would run out of room inside those 25 millimeter tubes, and so I had to keep it same length, or a certain length, and the I also had to figure out how to attach the pellets to the string, and the pellets had to act sort of like corks that kept those things in the belt tubes. And so we tested these things using a high-speed camera. Again, all sorts of sophisticated testing in developing this stuff. So I here right about where I'm sitting right now. We had a backboard that we were shooting the gun against, and a camera, high-speed camera, sitting off to the side. We analyzed how they performed and tailored them appropriately. They were coming out again for the nerds. They leave the gun. This being an air rifle that was modified. They leave the gun at about. I'm sorry about the. You can translate it to metric if you want. They come out and going about 600 feet per second, and within 10 meters, they're going 200 feet per second. So and at that point they basically start to fall. They leave the gun wadded up exactly like they are in the belt tubes, but within less than a meter, they're fully unraveled due to the turbulence of the air, and they chaotically spread apart. And this means, and this is, I suppose, an important thing that I didn't mention. Uh, uh, if you had a situation like, a football game with, tens of thousands of people in the audience, and somebody, let's say from your angry neighbor, decides to send a bunch of drones with explosives on them into the football game. Uh, uh, you don't want to have an aircraft with a fully automatic machine gun opening fire, right, to take them out. Uh, what I developed, on the other hand, you could, because within 10 meters, these are basically just falling. So you wouldn't want to get hit point blank in the face with one of these things, but compared to something like an airsoft or any other hard pellet, this is relatively safe because the drag that occurs on the Kevlar string that totally it just basically it rapidly decelerates. So our range, like when we set up the autonomous firing sort of a thing, it would come in and it would start firing right at about 10 meters. And that was what we decided to do based on the testing that was done right here, exactly where I'm sitting. So we analyzed how those things performed by looking at every at the footage of the drones on from the high speed camera, and picked exactly where they wanted to be when they went across the top of a targeted drone, and the downdraft from those propellers literally sucks the Kevlar kite string right into them, and down they go.
So maybe I will circle back a little bit to previous question. So you mentioned those cable drives. They are similar to capstan drives or something like that?
There's not what?
Are they similar to capstan drives?
Capstan drives. Uh, I'm not sure what I know what a capstan is. These uh, these I'm actually quite proud of this because I don't know anybody that has done this before. I have a lot of experience with cable systems from working in film. Our place, we this facility here, for example, we've turned out around 800 commercials and feature films here over the course of several decades. And a lot of that work were sophisticated robotic puppets for various commercials and things like that, and movies. And so I've worked with I've just done dozens and dozens of projects using cables. The trick with this was that you have in the drive system, you have two drums, and there's a cable that goes around each of the drum. But obviously, if you just had a single loop like a belt, it would slip. So we take several wraps uh, and around each one. So it's, sorry, I'm looking at things backwards, but so you've got your cable that is terminated on the drum and does a bunch of wraps, goes over to the other drum, does a bunch of wraps and back. Sorry, it's all backwards for me. Um, so how I terminate those cables on those drums is that I drill a tangential hole on each drum and I drill and tap that hole. In my case, with using English threads, I drill a tap hole for a 1032, which means a number 10 bolt with 32 threads per inch. I drill a tap hole for that, and I tap it at a 10 with a 1032 tap. I put the cable through it, through that hole or into that hole, and I put a plug screw in there that is either an 832 or a 632 plug screw. So that squeezes the, I choose which one depending on the thickness of the cable that I'm using. And basically the teeth of the tapped hole and the plug screw jam that cable into that hole, and the teeth grab the cable. So you're able to have a termination this way without anything sticking out of the drum, and that allows us to have several wraps. You can, it doesn't do like continuous rotation. Maybe a capstan drive does that. I don't know, but we got more than enough. We can do with something like 3 wraps on each drum, um, uh, all with one continuous loop from one drum to the other. Then uh, uh, we're able to get a full 360-degree rotation. I thought it was pretty sneaky because,
Yeah.
who does that?
Yeah. Thanks for explanation.
All right. I guess we took over an hour of your time. There are no more questions. So, Jamie, thank you very much for coming to us for the lecture and for being such a wonderful mythbuster as you are.
Well, thank you for having me and enjoy your evening.
Thank you very much. Have a good day.
Okay.